Hi, good morning, good afternoon, and good evening, everyone, depending on where you're joining us from today. I'm so happy to be here again after 1 month of break from being together with the AI 42 team. And I would like to start by welcoming my amazing teammate, who is Håkan. Hi, Håkan.
Hello, Eve.
And our amazing speaker, who is Johan.
Hi,
Hi,
Dave.
Johan. So I also would like to tell a few words about our speaker, who is a principal solution architect at Capgemini, and he is also a dedicated community guy. He started by working with Microsoft SQL Server, mostly with business intelligence, and then later he focused more on Azure Data Platform Services, IoT, Stream Analytics, and Snowflake, and combining his passion for Microsoft SQL Server with his passion for sharing knowledge. He started speaking at various events in the community as well. And I can't agree more with his words. This is also a way to give back to the community for all the things he has learned over the years. And I'm so happy to welcome you, Johan, at our event where you're going to talk about how to build your lakehouse in Azure. This is really exciting.
Yeah, so it's I'm trying to talk both on the terms of the architecture of the lakehouse, but I also want to talk because when you asked about speakers, you talked about storage as one of these solutions, and so I'm also going to focus a bit on the core of the data lakehouse architecture, which is the Delta Lake table format. So we will dive a bit deeper into that later on.
That is going to be a very important addition. And so thank you again for joining us. And maybe we could start by giving a bit of an introduction of what is AI 42. Are we ready for that, Håkan?
Yes, we sure are. Yes, so the motivation here for starting AI 42 comes from the recognition that there is no good starting material. So here we have AI 42. We are a strong team consisting of 3 Microsoft AI MVPs. And what we want to do is we want to provide you with a valuable series of lectures that will help you to jumpstart your career in data science and artificial intelligence. So our aim is to provide you with the necessary know-how so that it will help you to land your dream job, as long as it's related to the fields of data science or machine learning. And the concept is quite simple. So what this does, it involves professionals from all around the globe that will help you understand the underlying mathematics, the statistics, probability calculations, data science, and also machine learning techniques. And that may sound like a lot, but don't worry, because we will guide you through all of this. So all you have to do is to follow our channel and enjoy the content that we give every second week. So it will be filled with real-life cases and expert experiences. And you know, everyone has started from scratch. So don't worry, we are very happy to help you build your knowledge up from there. And you can always stop and rewind videos or ask for any clarification in the comment section. And we hope to be able to assist you on this wonderful journey and have you as a speaker one day. And we believe that by creating cross-collaboration with other organizations, we're able to give the best opportunities to broaden your network in the AI and data science communities. And with the combination of our offered services, we would support less fortunate people and organizations that are not that recognized yet, even though they deserve it.
And our organization is sponsored by Microsoft and Myers, and we are humbled by all the support we get from our contributors as well. So first of all, thank you Levent Pongor for all the beautiful graphical content, and Mina Murray for the cool intro music before our events. We are in close collaboration with C# Corner and Global AI Community, so our lectures are going to be available also on their YouTube channel, additionally to our own media. Nicolette Todd creates and reviews all our text content we use on our websites or advertisements and during our sessions as well.
So you can follow us here on Facebook, on Instagram, and on Twitter to become a part of a growing community where we will share knowledge and fun. And you will find every information that will bring you to an advanced level in the field of artificial intelligence and data science. And you can also watch our previous sessions, our recorded sessions on our YouTube channel, and you can find our upcoming sessions here on our Meetup page.
And the code of conduct outlines expectations for participation in our community, as well as steps for reporting unacceptable behavior. We are committed to providing a welcoming and inspiring community for all. So please be friendly and patient, be welcoming and be respectful with each other. You can find out more about our code of conduct at the page over there on the site.
Yes, so should we get back to Johan?
Yes, I think so. Hi, Johan. Welcome back.
Hello.
I hope you are just as excited as me about the session.
I am. And apologies to all that I had to cancel because of I got COVID last time. So I'm really eager to get back into it.
And we are
Yes.
very happy that you are here with us now.
All right. So let's dive into building your data lakehouse on Azure. So
Yes.
just quick vanity slide. That's me.
One
Nick
moment, Johan.
One
Yes,
moment.
And we are gone. Okay, good. So quick intro about me. As mentioned, I am a principal solution architect at Capgemini. You can find me on Twitter at Intolerance. Just reach out for anything. So as I mentioned in the start, I reached out to AI42 because when they were looking for storage, because I'm really interested in the data lakehouse architecture, and specifically the Delta Lake tables that are underneath here. But I thought we could look back a bit because the data lakehouse is something that tries to answer challenges from previous historic solutions. So I would like to first dive into what is data lake and data warehouses, so the history of everything, and then look at the data lakehouse, and then how to build it. So very quickly, the data warehouse has been around since around 1988. It evolved over time, and it involves, of course, schema on write data. It's a relational database centric system, and it is made to store historical data that needs to be transformed and aligned so it can support cross-business or cross-system querying for the entire business. And typically you do an ETL, so extract, transform, and then load or store the data afterwards. And this cross-system querying means that it's very good for business decisions or enterprise-wide reporting. But it also means it has a focus on high data quality and exact numbers, which means you get very long development life cycles because you are focusing on making sure that your numbers are correct and everything is sorted properly. Then you have the data lake, and the data lake itself gained foothold around 2011, and it tries to answer some of the pains that we were starting to see in the data warehousing side, and specifically around the big data. Of course, depending on which marketing department you talk to, they will talk about 3, 4, or 5 Vs, but let's stick to volume, variety, and velocity, which are things that the relational database systems of the time were struggling with. And the typical data lake's variety is the raw data lake. And then you have a layered data lake or a business data lake. And the principles of this business data lake, the first principle is the same as with the raw. You land all the information you can as is with no modification. So it's a one-to-one with the source. Then you encourage line of business to create point solutions. You let the line of business decide on the cost and performance for their problems, which means that IT can concentrate their governance on the critical points only. And the corporate view, hence the data warehouse view, is just another line of business view. And any kind of information is information, so even if it's unstructured, that's fine. And of course, you shouldn't really assume that the data lake contains everything, even though we try to land all the information we can in there. And scale on the data lake is driven by demand, so you can scale down as well as up, versus a data warehouse where you have your fixed box or your fixed VM, and it's a bit more difficult to throw in more cores and memory on it. And of course, the different layers in the data lake serves different use cases and users. Typically, data scientists want to look at the raw data, whereas a business analyst might want to look at more curated data. And of course, the CXO level prefers just their paginated reports or their dashboards. And the data lake, unlike the data warehouse, is very good for trends and ad hoc analysis. And because it doesn't have that focus on exact numbers and data quality, it has a lot shorter time to market development cycles. Yes, then enables data science and data self-service, but you get a problem with data swamp because you load all the data in and you don't necessarily have a proper governance on it as you would on a data warehouse. Data lakes struggle with the lack of ACID support, so atomic, consistent, isolated, and durable, which is something a relational database is good at. And it can have slower query performance because you're storing just files on a disk somewhere. And the enterprise data warehouse is well established, so why should you throw away the work that has been done on it? Additionally, a data warehouse, as I said, is very good for the cross-system querying, whereas a data lake is not, because you don't align the data, you don't align business keys or make sure that your customers are aligned and so on. So of course, you can fill the shoes of a data warehouse with a data lake, but not without taking on the parts of the form and function of one. So again, you get back to the pains that relational database systems or data warehouses have. And of course, both of these are valid. So data lakehouse tries to deliver both on the regular enterprise data warehousing systems with your transformed and normalized tables and data marts. And then you have your big data analytics in your data lake. And of course, this also empowers self-service BI, both from the data warehousing side, but also from data lake. And it enables this self-service analytics or ad hoc analytics, as well as data science. But to perform large data set, you need to have the proper services in place, and which is, again, something that you need to try to look into when you're building your data lakehouse. And unless you have proper governance in place and a proper data catalog in place, you will still risk ending up with a data swamp. Because if you deliver data, how can your user find it and make use of that data? And that is the key point. And of course, also you want to make sure that the users, when they're connecting to the data lake or the lakehouse, that they can know what data to trust as fully qualified and tested, and what data is not tested and might not be as accurate as you want. So the features of a data lakehouse is it has transaction support, so it can receive batch files or streaming one-on-one transaction. It has schema enforcement and governance, so you can update or change your files, or your columns, to make sure that whenever you insert a new column, all the rows beneath will get that column inserted into it, and so on. And it supports BI tools of all sorts. And important, again, this is also part of the data lake. Storage is decoupled from compute. So you can store the data, and when it's not in use, you don't really pay for a lot of money for that data. Unlike in a relational database, whether that is on-prem or in Azure or another hyperscaler, where if you buy or rent a SQL DB, and put data into a table, you will pay for the compute and storage cost of that server or that table. Data Lakehouse is also open, so it shouldn't be locked into one specific vendor. And it should support a diverse amount of data types, depending on, again, as any relational database system should. It also needs to support diverse workloads because you should have both live and batch loads and so on. Everything should be able to be supported into the Data Lakehouse. Another key feature here is that you want to have end-to-end streaming. So you can do live updates, live streams through the Data Lakehouse and out into a live report if you need. Though for most cases, most users don't really need live updated dashboards. They just need every 10 minutes or so. But if you ask them, they will always say live because that sounds cooler. So the Delta Lake is at the heart of the Lakehouse. And the reason why is that, for one, it supports the openness of the principles. So it's an open source format. It brings the ACID principles to the data lake. So it supports all hyperscalers as well as on-prem. But it makes your data updatable, deletable, changeable in a way that regular file systems, or if you try to do anything with a Parquet file itself, you need to take that file, load it into memory, do the changes, and then store it as a new file. In Delta Lake format, that takes care of everything for you. And it is a unified batch and streaming, source and sync, so you can stream data out of a Delta Lake table, and you can sync live data into a Delta Lake table. And it enforces schemas. So it's a schema on-write system, and it makes sure that all the data that is stored in that proper schema. It also supports schema evolution, and as I mentioned, that is if you insert a new a new column, it will support and update the rows underneath with empty values for those rows. It also has a transaction log, which means that you can see changes happening over time and manage them. It also supports time travel, which means that you can go back in time and look at how that row or how that table looked like a week ago, a month ago, if you want. Everything with a simple command. And as I mentioned, because of the ACID principles, it also supports updates and deletes. So you can do merge, slowly changing dimension types of queries on the Delta Lake table. And it keeps track of audits, so query logs, what changed when. It does not tell you who looked at a certain row, but it still does tell you who updated or deleted the row. And underneath the hood here, data is stored in a Parquet file or in Parquet files. And for that, I thought I'll just show you how that looks like in storage account. So let's see. So these are just the files I have stored or picked data from. So that's a standard yellow taxi data set. And then let's look at where did I store that file? Sorry. Nope, it wasn't there. Sorry. Yeah, here you are. So these are Parquet files. and you partition your table as you want. And if I open up this to a data frame, I will query it as it is a Parquet file. And that will, of course, take some time to do. I'll see if I can get that cluster up and running again. And it's not started. Okay, never mind. That we'll skip that for later on. I'll just start it so I can get it running. Additionally, with your Delta Lake, you also get the log files. And of course, this always takes a lot of time when I'm running demos. That's typical. And here you see the transaction logs being written as JSON files. And they can also then be opened up and looked at if you want. But the transaction logs are written as JSON files, and the data is stored in Parquet files. And you can query them independently, or you can loop through the Delta API that is wrapping around the different Parquet files and keeping track of everything. But let's see. I'll just show you something more here. What I've done when I created this Delta Lake table, I've read a CSV file, and I've stored it first as a view in my, oh my god, my brain is stopping. So let's just skip to the I've created that view. Then I've created a table on top of our Delta table. And what I've done is you define your table. It's Spark SQL code. And you define your table using Delta, and you tell it where to store it. And then I inserted data into the table from the view that I had stored. And then I can query that table afterwards if I want to. Does take some time. And while I was querying, I also did update on the table, setting some columns or some rows that were stored, and changed the vendor ID from 1 to 2. Which means that I can then afterwards look at the history, which is again looking at the transactions to see what has changed. And for some reason, it's not showing. That's fun. This is Demogods appearing again. So there you go. I now have seen what has happened. I have my transaction log showing. And I can also use something called time travel to go back in time and see what that file looked like when it was started. And because that was an empty table, this is what it will look like. Sorry, that was a... Yeah, so as you can see, it doesn't really tell you much in this case, but when you're storing that data and dumping data into it, you can then use this version as of and look back to version 1 and version 2 and version 3 and look at the changes that have been happening over time. So it makes sure that you it stores transactions, it makes you able to do time travels and then do restores on those. And all this again supports the Delta Lake table format as a really, really good option for you, because it does most of the things that a regular table does or a regular relational database system does, but it stores it just as a file, and Parquet is highly compressed, so it is effective. The only challenge in this demo is because I'm running things on Synapse. If I had started using serverless SQL here to query it, it is a bit slow. It's still not as performant on Synapse SQL as it would be on a Databricks system. But all this means that even though you're physically storing things in Parquet files and you store your JSON transaction logs, everything you connect to here is connected. If you can use an SQL endpoint, or you can use Power BI, for instance. I think also now Tableau and Qlik supports Delta Lake because it's an open source format, so it's easy to connect to. And you can load that table into your reporting system without having to go through a dedicated SQL or relational database system to do so. Of course, you can query a Delta Lake table using a SQL endpoint as well. So again, the Delta Lake is at the heart of the lakehouse, and the lakehouse pattern looks at different stages of transformation. So you have your bronze table, which is the raw data lake table, data lake layer. And if you're looking into a relational data warehousing kind of system, you typically have an operational data source, or you have a staging system. So one-on-one towards source, that's your bronze tables. Then you have your refined tables. In a data warehousing system, that would typically be your enterprise data warehouse tables, or your transformations tables, where you align things like customer IDs or clean up date formats and so on. And typically this is where you can allow your business analysts to be allowed in, because they can look at and explore data that hasn't been fully transformed, but at least has been cleansed and prepared. And then in your gold layer, that's your data marts or your model data. You can even put a semantic model in here if you want. And then you publish that and allow that for your reporting designers and your business analysts and your end users to connect to and look at. And again, it is open source. It's available and supported on all the different hyperscale vendors, as well as on Hadoop on-prem. This this picture is a bit old. It is also on Google now, even though it doesn't say so in this picture. And for a flowchart of how this Delta Lakehouse or data lakehouse should look like, in a traditional data warehousing system, you will look at ETL jobs with some messaging queues, second round of ETL jobs, streaming analytics on top of that, or you store things in Parquet files or in Avro files, do some more transformation on them, push that into a Parquet file or on an Avro or CSV or whatever, and then you store that data into a data warehousing system of some sort, be that Synapse SQL pools, or if it's SQL DB or whatever. And then that is what is being exposed to your business users and your business analysts. And you can also then have Parquet files pushed out to data scientists. And in data lakehouse format. This is then where you can replace your Delta Lake, your Parquet files with Delta Lake tables. And because it's a unified streaming system, you can avoid having that separate functionality with the streaming components in your ETL jobs on the top. But of course, we also want to have waffles with your coffee, or coffee with your data lakehouse, and it's a serving layer where you want to push that data out. So, okay, something happened on my file, sorry. So compressed files in the data lake is very cheap. We're talking about 1/5 of the price of an Azure SQL DB. You still need to have some sort of compute to read the files, whether that is serverless SQL, or you store this as views somewhere, or you have a dedicated cluster running that can be hit by Spark cluster, can be hit by whatever, or you pull that data in and process it on a Power BI side or on your local computer. Databricks is the brains, or are the brains, or the company behind the data lakehouse architecture, and they announced a lot of features during the last 2 years that supports the data lakehouse architecture and makes Databricks a very full-fledged, full-service platform. First of all, you have Photon, which is an analytical query engine. So when you're querying things like group by, max and min, sums, and so on, if you do that on a cluster that is Photon enabled, you will, when you're looking at the query plan, you will see that you go from the normal Spark engine over to the Photon engine, and it will perform a lot faster. But of course, it comes with a premium price, so it is a question of tuning your price performance ratio to see if that's worth it for you. Serverless SQL functionality in Databricks is also announced. I haven't been able to test it myself to see the performance of it, but it is purported to perform a lot better than the serverless SQL within Synapse right now. Delta Live tables came out in live. It was reloaded into general availability this year. And that means that you get your data transformation and data orchestration within Databricks. Previously, Databricks has not been very good at doing orchestration of the data, but Delta Live tables allows you to do that, and allows you to also see more of a lineage kind of view on top of your transformations. And then you have Unity Data Catalog, which is still in preview, but looks to be a data catalog that is technical. It's not meant for end users, or it's not very user-friendly right now, at least. But it gives you insight into, again, publishing data sets that you have, and it allows you to even look into who queried what data when. So it is a very powerful technical data catalog. And these are all components that are needed in your data lakehouse architecture to survive or to push out the proper functionality. And this means you get your Delta Live tables to orchestrate. You have your serverless SQL and your Photon engine for BI users, and you have your serverless SQL or even clusters available for your data scientists and business analysts that want to go into versus the silver and bronze layer in the Delta Lake. And of course, Unity Catalog across all to be able to for all users to find the data that they want and where they can find it. Then you have Synapse, which is also, as I showed in the demo, I was sitting in Synapse working. And Synapse is is a bit complex because it's one name, but it has several different services that are bundled together. You have Azure Data Factory, which is now then Synapse Pipelines. You have Azure SQL Serverless, so serverless SQL points, which means that you can attach them. They are posted automatically. Unfortunately, they don't cache their queries, but you pay on the gigabyte that is being pushed through your SQL endpoints instead of paying for a dedicated machine when it's running. Of course, it also means that whenever you do any complex joins or anything, that query plan, if you're a bit careless, that query plan can quickly be expensive because it's not the final result that is what you're paying for. You're paying for all the data that's being pushed through and then computed and then served to you. SQL Data Warehouse, now named dedicated SQL pools. So that's the massively parallel processing data warehousing solution of Azure. Then you have Azure Spark, and you have your workplace, so the Synapse Studio. And Databricks and Synapse is very good in that aspect, that you have one unified place for your users. Both of them have the same weaknesses in that managing all the workbooks can be quite of a challenge, and none of them are really good at DevOps Git integration right now. Hopefully that will change, but right now both of them are a bit meh in that kind of aspect. What Synapse has now, which is quite interesting, is that you have an Azure Data Explorer, so which is time series data. Using a language called Custo, you can do a lot of powerful queries on time series data that has previously been quite a weakness within both the Azure services offering as well as in Databricks. You have live streaming in Stream Analytics, and you have machine learning, though only partially, because you don't really build. Of course, you can build your machine learning models in Spark and then store them in Onyx, or you can do that in Azure Machine Learning as well, do your training, everything, and then store that machine learning model as an Onyx file, import that into your SQL data warehouse, and then, of course, all users can trigger that model as part of their SQL query when they're running against the SQL dedicated SQL pools. And Databricks themselves have certified Synapse as the second data lakehouse compatible system. I know there are a lot of other vendors that are pushing to make their systems data lakehouse compatible, but at least last time I checked, it's only Synapse that is full on. And that's because you're using Azure Spark, you support Delta Lake natively. The Synapse pipelines, as well as Azure Data Factory, supports Delta Lake source and sink, though if you're using the data flow part, it's only as an inline sink. It's not as a direct target. And then you have serverless SQL pools that builds the views on top. Or you can read Delta Lake, and build views on top of those. And then those views are exposed as a normal table or a normal view to end users. Power BI as well supports Delta Lake directly, so you don't have to go through a serverless SQL pool to load data in. You can just load data in directly. And then what I forgot to mention is that Purview, which is the Azure Data Catalog version 2 with extra functionality and was yesterday renamed to Microsoft Purview, is their data catalog and data governance tool that allows Synapse and Purview together to form this end-to-end data lakehouse architecture. I'll look a bit closer into this. I showed you the demo on how this will perform when you query against it, when you write data into the file. There's a second option as well. In this case, I have I have exported a table from a dedicated SQL pool into a Delta table called trip. So you don't have to go first create the table, Delta table, and then store data into it. You can actually, when you're querying and creating your data frame, you can write and save it directly. The only challenge in this aspect is that it doesn't support, unlike the normal writing of your Delta Lake table, where you can specify which place it's stored. When you do it like this, you are not allowed to specify the saving location, which means that you only save it on the default storage account. And this again allows you to query as using Spark SQL. You can query that table as you can by going into your workspace and querying. Let's see if I get this is trip. Let's do this in I'll double check if I have it here. And here we go. If I run this query, it will probably run a bit faster. Yeah, it's in 5 seconds. When I run this using Spark SQL on the Delta Lake tables, it runs in 3 seconds. The way to use serverless SQL pools on top of Delta Lake is by using the open row set command. And then you can just specify where it's stored. You specify the rows. And what is, yeah. You specify the columns that are being returned, and then you can put order by, you can put where clauses, and do queries on top of that. But of course, it is a bit slow. This one took 27 minutes to load the full. This is 5 million rows, I think. So it takes some time. So it's using Synapse on top of Delta Lake is still not perfect. It's still a work in progress, but it's getting there. Databricks is a lot more mature, and it will also help you a lot more in delivering a full data lakehouse architecture to your users right now. But both of them are very solid options. And again, it all comes back to what your end solutions are and how you want to deliver that to your users. And with that, I think I'm actually done. Do we have any questions?
Yeah, so let's see here. So I can't see any questions right now, actually. But we'll see here. Maybe Eve, do you have any questions here for Johan?
Okay, so I don't I didn't think about much of the questions yet, but I'm also, because you actually answered some of my questions, like whether you would prefer Synapse to Databricks. What are the coverages? What are the problems maybe with the Synapse coverage? Because that is something that not many people have experience with yet. So
Yeah, I can add to that though, because yes, Delta Lake is an open source format, but because Databricks are the ones who made it, they have some secret sauce, so to speak, on how they treat the Delta Lakes. So it is quicker, and because the serverless SQL pool points in Databricks is a bit faster than in Microsoft in Synapse, that is a preferred approach for me. But you can, of course, mix and match, simply because when you store data into your Delta Lake tables, it means that you open up for all the systems. Even though you prefer to do everything in Databricks, you can still let people, if you have a Synapse instance installed in your system, you can still open up for people to query against and import that data in Synapse.
yes.
And also, do you have any good links to any tutorials if people are inspired after this talk to learn more about where should they start?
Yeah, I recommend people go to delta.io, which is the homepage of the Delta open source format. Databricks gave it over to open sourced it to the Apache Foundation in 2020, I think. So they are taking over the development of that. So delta.io has lots of nice features and lots of good information. Also, there is a very nice cheat sheet for Delta Lakes on Databricks. I share that link into the chat, I think. So Håkan can share it further on.
Yes.
And I've seen some discussions on Twitter saying that Delta Lake is and Data Lakehouse is a hype. I don't agree with it being a hype. It's a bit too soon for that. But people are moving into it. I see some very nice case studies of larger corporations who implemented the full Data Lakehouse architecture and are performing really well. So it's a strong option for people and makes it a lot more vendor independent. You can move it from, there are even templates to move your Delta Lake tables from AWS to Azure in the data factory. So it makes it so much easier to change vendors without being locked in.
Mm-hmm.
Yes.
And it's now they're changing it, so now you even have support for things like custom so primary keys and so on. So yeah.
All right. Before continuing the discussion on the architecture and layers and all that, because I'm also interested in that side as well, I would like to ask the audience if there are any questions, and if so, please put it in the chat so we can discuss and get you some answers. So you mentioned that there are like different the data lakes, like the raw and the business one and so on. And we also talked about different architectures, for example, like this layer architecture, which is getting kind of hype nowadays. I see from at least my point of view, because I am new in the consultancy world. But how do you see nowadays how much focus is there when moving your data into a data lake to focus on the layered architecture as well?
Well, the main parts people are focusing on tend to be either looking at traditional data warehouse or they're looking into data mesh. That's very, 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 very buzz. But when they are looking into, specifically if you're coming in from an on-prem data warehousing kind of solution, and they're looking into, should we go for a data lake or should we go for something else? It's typically pointing them to the fact that when they're doing data warehousing, they do have an operational data source or a staging environment, and that is typically the raw layer. And whether you're going for publishing or putting in your serving layer, where that's where your end consumers come in, end users come in. If you put your serving layer into a database, relational database, or you put it into serverless SQLs, that doesn't really matter because that's something you do later on. But to store your staging or your raw data into a relational database is throwing money out of the window. So getting them to understand that and to store data just as files in that bronze layer or that raw layer, and then look into, should you go for a 2 or 3 or 4 layered data lake approach, or should you put the second and third layer or fourth layer into other kinds of systems, such as a SQL DB or a SQL data warehouse? I see some distributed solutions because of, for instance, Synapse dedicated SQL pools have concurrency limits, which means that if you are expecting a lot of questions or a lot of queries hitting your data warehouse at the same time, then you can start running into problems. So then they distribute the serving layer. So they have their what data lakehouse architecture says as a silver layer. They put that into data warehouse, and then they put the gold layer into SQL DBs. So they distribute that out. And then they have either a semantic model on top of that. For instance, Power BI is a semantic model, or you can use Azure Analytics and Azure Analysis Services if you want. And that's where your CXO or your report consumers hit. So that's 4 layers. If you do the same thing in data lakehouse approach, you put everything into bronze, silver, gold, and then you can choose to have that semantic layer sitting between the users and the gold layer if you want.
Yes.
But of course, because you have Power BI or Tableau or Click, some people don't want to have that semantic layer. They want to put that everything into the reports. So
Yes, it really depends on what the customer would like to get exactly, because it's like a different setup everywhere.
yeah, there are some patterns, but all customers are, or at least like to think they are unique. So
Yes, and we would like them to feel like that as well.
yeah.
All right, thank you, Johan. It was a really nice session, and it was a very beneficial one. Also, I'm not sure if the code that you were using for your demo is available, or is it something that you can as well share with our
I can
audience?
share that code. I'll just make sure that I don't share any. I don't think I share any sensitive thing in it, but I'll just double check. Otherwise, it's freely available. So I'll share it with you.
Thank you a lot. And with that, I want to say a big thank you for your session again, because it was really nice, and we learned again something new today.
It's always
And
good to
really,
learn.
yes, that's why we are here. Okay.
Yes.
Håkan, do you have anything to add?
No, I also thought it was a very interesting session here. So thank you very much, Johan. I hope we can have you back here in the future session.
I hope so.
So, Håkan, do we have anything to share in the end of the session?
Yes, we have some more information here. But Johan, could you please stay on StreamYard while we are just finishing up things here? So,
Thank you, Johan, again.
yes. Yes, so we would just like to give some promotion here for what will happen next time here, which is May the 4th. So then we will have a session with Pete Gallagher about home automation with Azure Percept. So please set your schedules for that, because that will be also a really interesting session.
And let me add to that, sorry, Håkan, because he promised us that this session will be, of course, in Star Wars style and Star Wars theme, because of we really wanted to celebrate this day with some Star Wars content. So stay tuned.
Yes. And then if you want to come and present a session here, we also have an open call for papers, so you can reach us on Sessionize on this link that you can see here. And yeah, we look forward to have your contribution. And with that said, I think we can say hi to everyone, and hope to see you in 2 weeks' time.
Yes, thank you again for joining us. I hope you enjoyed it today. Have a beautiful day or evening, depending on where you are now.
Yes. Bye-bye.
Bye.